Alright, before I move on, I want to show you a quick demo in Excel that helps prove the central limit theorem visually. Now, I have added this as a resource to this lecture if you'd like, but there really is no need to follow along here, especially since I will be using a bunch of dynamic array formulas. Now, let me walk you through what we're looking at here. This is an array of 10,000 randomly generated numbers between 1 and 11. That's going to be our population, which makes our population mean 5.95 in this case, but if I go to refresh and generate a new population, you'll see that it'll stay oscillating right around 6, which makes sense because the randarray function generates random numbers from a uniform distribution. And if we look at the distribution of our population, we can confirm that with all the numbers having pretty much the same frequency. Key takeaway here though, this is not a normally distributed population. Now, let's say that we were to take 100 random samples of size 30 from this population. Well, we can simulate that in Excel. Let me use the sort by function first. And what I want to do is rearrange these random numbers randomly again so that I know that I'm taking a random sample. So I'm going to sort this array by a random array of the same size, so of the same number of rows. Again, no need to worry too much about the formula here, just know that it's returning this same array, just ordered in a random way. So what I'm going to do then is just take the top 30 rows from this array. That's going to be my sample. We can see it here. And then just grab the average of these 30 numbers. Do the average. And we get 6.6 for our first sample. Let me just fix these so I can apply it down. Press enter. We get 5.7 now, which is plotted right here in our sampling distribution of the mean. And let's see what happens when I apply this down. And would you look at that, our sample means do follow a normal distribution around the mean of the population, which we know is 6. And if we were to calculate this now and generate more random populations and grab more random samples for those populations, we'll see that the same normal distribution around that mean continues to show up. So there you have it. Because of the central limit theorem, we can now assume that any large enough sample belongs to a normal distribution of sample means that is centered around the population mean. And we're going to be able to do some pretty amazing things with that.